Okay, we're live.
All right.
Today, myself, Max, and Ben Jacobson, in our respective apartments, me in Berkeley. Ben, where are you at?
Soma. Hello?
Whoa, there's some massive delay there. Oh, do you mind? Oh, I must have, there we go. I had the video YouTube link open, which was playing back. Sorry. Okay, I'm here in Berkeley. Ben, where are you at?
Soma.
Cool. So the first time we worked through this, we read the first lecture notes of MIT's distributed systems class, and we got started on their first lab. So Ben has been kind enough to make a GitHub repo of the code, which I think was explicitly against the course rules, but the course is super over by this point. I think it finished last spring, so we're going to be sharing all the code we're working on right now on the live stream and on GitHub, which I'll drop a link to in the group chat. But today, what I'll do is I'll screen share, and me and Ben will be working through a bit more of the lab. We got not crazy far, but we'll see how far we can get today.
A little more progress, hopefully.
Oh, for sure, for sure. So I'll go to screen share mode. Can see me, Ben?
Yep.
So I cloned the GitHub repo, which I left a link for in the group chat, and I'll go over to my terminal and check out whether I can run the tests. I'll make the font size a bit bigger. So source code, and the first lab was lab RPC, right? Is that correct? No, MapReduce.
MapReduce,
yeah. So the instructions from the lab itself, lab 1, was to run tests by doing this certain thingamajigger. Echoing or changing directory into the MapReduce directory, and then running just the sequential tests.
Yep.
So I'll try running those sequential tests, but let me first check my Go path. I don't have a Go path. I may not have Go installed. Let me try using Homebrew to install Go. Install Go on Mac. This is going to be pretty rapido, I hope. We don't need to use Homebrew, actually. We can just use here. The official page. Download for Mac. Cool. Only 100 megs.
Cool.
So how are you feeling about our Go skills at this point, Ben?
You know, they could be improved.
Oh, for sure. For sure. I'll take off screen share while I install this because it shouldn't take more than a minute. I'll need to type in my password. I, unlike Ben, don't really use IDE software. Like I forget the name of the exact IDE that you were using before to write Go code. Which was it?
It's a new one from JetBrains for Go. I forget what it's called.
Okay.
But we don't have to use an IDE.
Okay. I'll use trusty Vim and my Mac terminal emulator. Okay, installed. Any other steps? Let me see if I've got Go now. I don't have Go in my path. It says where it gets installed to, so I'll need to add it to my path. So let me do that real quick. Oh man, the screencaster tool that is showing all my keystrokes is like blocking my terminal. Super annoying. Maybe I can change the location of it on my screen to the bottom right instead of the bottom left. No. Awesome. All right, well, I'll make the font size a little smaller. What I'm doing real quick is adding the path to the Go executables to my bash RC, so I can access the Go command line tool from my, there we go, from my terminal. And let's see what the Go path is. We might need to set it to be. So Go path is not set for me yet, so I'll need to set it to what they tell me to in the fucking lab. All right, I'll go back to screen sharing since I've got everything set up now. So they want me to CD into the root of the labs Git repo. So I'll go back down to here. I'll export the Go path as the current working directory, and I'll CD into MapReduce. And so the test is ran by running go test run, and then we'll specify specifically what tests we want ran. Cool. So we're getting somewhere.
Yeah, we're running here.
Something syntactically wrong or type checking wrong in our common map file. So let's check out commonmap.go. Line 49, cannot use ihash result.key type int as type float64 in argument to math.mod.
Yep.
So it looks like ihash, which we're invoking to get the hash key for storing the results of our map function, is returning a float and not an integer. And so the mod that we're trying to take of that hash isn't working. So we go check out ihash. Looks like it is returning an int. Maybe the other value, nReduce, is not an int. Let's go quickly look up the signature for math mod. One weird thing about Go is that when you search for any kind of, documentation online or Stack Overflow type information online, you got to search for Golang, because if you search for Go, the rest of it is garbage. So let's look for func mod. So mod takes both. I assume the syntax means that both x and y are floats.
Floats?
Yeah.
Oh, so we're trying to pass an int instead of a float.
Yeah. So what's an easy, are you familiar with an easy way to cast integers to floats in Go? All right, let's look that up. So what we're referring to here is just the conversion of a variable whose data type is an integer, meaning a whole number, with no decimal point, while Go is very strict, and the function we're trying to use here, modulo, is demanding float, which is kind of bizarre.
Yeah, bizarre.
Convert an integer to a float number in Golang. Looks like we can create temporary variables. This is by far the most popular answer. There is no float 64. There's no float type. There's a float 64 type. You could also float 32. Yeah, we don't care. So we don't need it. It looks like it's a built-in global. So what we can do is create. Whoa. Oh, what's going on here is it looks like we're using tabs rather than spaces to do indentation, but it doesn't matter. We'll just cope with it. Can we redefine a variable, maybe, and reduce as, well,
I suspect I'm not going to be able to do that.
N colon equal float 64 of nReduce. So we'll create these temp variables, or set this temp variable every time we go through the loop. And we'll also set, maybe let's name it m modulo n, and we'll just make that float 64 of the result of the hashing function. There's probably a more syntactically smart way to do this in Go, but whatever, let's give that a shot. Cannot use r type float 64 as type int in argument to reduce name. Okay, we're getting a little farther.
Yeah.
I was on line 60, 50 something. So yeah, this shouldn't be a float. So we can redefine R as int R. This is so jank. But yeah, let's just do that. So back to like where we were in the lab. Do you recall we're editing the doMap function right now?
Yeah.
For people who didn't watch our first video, which is probably most, where were we at in the lab so far?
So we are trying to get the doMap function to do all the things that it needs to do. So we can read the comments and where in the
No. In the code works too. The course gave us this source code, which is what the Git repo is that we're working on.
Yep.
But like you said, there's a bunch of documentation strings about the functions that we're supposed to stub out the actual behaviors of what the MapReduce code is supposed to do. So okay, so we were getting the hash of the result of the map function in order to figure out what file we're supposed to write results of the map step of our MapReduce algorithm. Do you remember what the intermediate RF name means? Does that get, we don't use it for anything.
Not yet. I think this is, well, maybe we should just print it out and see what we get.
Oh, it's the intermediate, okay, I'll do that. It's the intermediate reduced file name.
Yeah.
I'll just make it really super explicit. Intermediate reduced file name. So it's looks like we're appending the result of our map function to the intermediate reduced file name. So yeah, you suggested let's print ln the intermediate reduce file name. Let's try running tests. Undefined. Oh fuck. What I print ln. Cool. Well, the test failed, but we're getting printed out.
We're getting
kind of helpful. So,
some files here.
Yeah, so I think we're almost done with implementing the doMap. What we're not doing is we're not writing the results of our map, each of our map tasks into their intermediate reduced files.
Yeah.
All right, now we gotta learn file IO for Go. So we have this file name. Let's go over here and keep a pseudo idea of what the file name looks like. So what we're going to want to do is open that file name. I'm going to do some more pseudocode. Open intermediate with the F file named F. We're going to append, specifically, we're going to append the key. Is that right?
I'm not sure. So we get the results from the file. So we get the results from the function that we pass in. I'm guessing we store the value, maybe? Result.value.
Okay. Oh, what we can do is perhaps we can print out result, the key and value of the result. I think I recall that the value was like an empty string, and so it's actually the key that we want to pass through. So we want to append key. So what I did was I added printing of the result, each result's value in addition to its key. So let's try running the tests again. Yeah, so you can see it's printing out an empty string of some kind, or that value is just basically not set.
Right, okay, that's right.
Okay, so, all right, let's read the comments because the comments are probably pretty helpful. So doMap manages one map task. If it reads one of your input files in file, it calls the user-defined map function, mapf, which we're doing on line 45.
Okay.
DoMap calls the user-defined map function for that file's contents and partitions the output into n reduced number of intermediate files. Okay, cool.
Partitions.
So we will need to write this function. No kidding.
Yeah.
The intermediate output of a map task is stored as multiple files. Okay, one per destination reduced task. The file name includes both the map task number and the reduced task number. Use the file name generated by reduced name. So they've already given us a function for getting a file name.
Yep.
Where R is the result of what we were doing with modulo and calling ihash. So we're getting the proper intermediate reduce file name. We just need to implement the pseudocode right here. So yeah, let's do that.
Okay.
They mentioned about using JSON to serialize the key that we're passing through. We don't need to do that right now. We can probably just add the raw result.key. So we're creating these intermediate files, one per reducer. In our case, I think with our first test that we're trying to get to pass and which is failing, nReduce is 1. So we're really only writing out to one file.
Yep.
All of the map results.
Yep.
So let's go Google Golang append line to file. Oh, Stack Overflow, so helpful.
Nice.
This answer works in Go 1. We're using Go 1, I believe. Go version? Cool, yeah, we are. I'm using 1.9.2, which I think is the same that we were using last week on your computer.
Let me see.
This looks very good. This is the most voted answer. It's accepted by the question asker. I think we'll need to add a couple imports at the top of our file, particularly to get OS stuff. Yep. But otherwise, let's just rip it off. So we don't import OS yet, so we'll add OS. But otherwise, what I'll do is I'll paste, copy, paste. So there's a lot of stuff going on here in order to open a file and append a line to that file. Want to spend like a minute or two and we'll break it down together?
Yeah, so I think we're going to need to open up this file and we're going to need to stream key and value to it ultimately. Although for this example, we only need key because value is empty. But in the future, we're going to need both, I think.
So right now, we'll write just the key to it.
Okay.
What we could do is we could do what you're suggesting, which is pass the key and the value. We could do it like with a delimiter or something.
Yeah.
I'm making some assumptions here about how Go works, whether you can concatenate together string variables on the fly.
Yeah.
Another thing is we could do some kind of serialization of our key, our result object into JSON, a JSON string. For now, like you're just suggesting, let's see if we can just write result.key. But yeah, the result of map functions are not always just a key. They're also key and value often.
Yeah, we can try that.
All right. The other weird stuff going on here is that in opening the file, there's a bunch of explicit second and third arguments here. This is the mode that we're opening the file in. So in Linux, like programming architectures or Unix file systems, there's different modes that you can request the operating system give you access to a file. So we're getting the file in an append mode so that we're indicating to the operating system that we have a write lock on the file or that we're going to be performing writes that need to be flushed to the file.
Yep.
So if there was parallelized writing going on to the same file by two different pieces of software. This last argument looks like it's the permissions on the file. We might encounter a problem if this file doesn't exist or some BS like that, but I'll save the file. Should be writing to the file. So what I'll do is I'll add another print statement. Writing result.key to our intermediate reduced file name.
Yeah.
So that should, yeah.
I wonder if defer close, does that get run? What is this going to get run for each block of this range?
Yes. So defer, man, we're opening a whole can of programming language whoop ass on ourselves.
I just don't know when that gets run.
So I think defer hints to Go's compiler or runtime environment that this f.close, closing of the file handle, this f variable, should happen whenever we're done with the f variable. So whenever f goes out of scope.
Yeah, okay, so it's at the end of this block.
Well, f will probably hang around past the block. Like if we were to add print line and try printing f, f would be the value the last time this loop was, the last iteration of this loop.
Yeah.
So it's probably, defer probably runs f.close when this function returns. But I don't think it's like a performance issue for us to have that there as opposed to like here, you know.
Right.
We can just give this a shot and see what happens. We should now see this printing going on saying that the result.keys are being written to the intermediate reduced file name.
Yep.
So I'll run our test again. We're not getting notified that rows are written to the intermediate reduced file name. We are, however, getting other way more heinous stuff. Panic. No such file or directory. So, yeah, when we're trying to open the file in append mode, it's complaining that that file doesn't exist yet. So we're going to need to do some pseudocode like if intermediate reduced file name does not exist, you know,
then create it, and then you can
create file, something like that. In Python, there's a really easy way to do this. Well, Python doesn't care whether files exist or not when you try to open them.
There's probably another function helper, open or create file.
Okay.
But I wouldn't.
How to append? All right. Their official docs are going to be the least efficient way to figure this out. So RDWR probably is read or write permissions. We probably need ocreate permissions. So maybe we could just add it as another option.
Yeah.
I really don't know what this pipe delimiter is. Do you have any? I'm guessing it's some kind of binary.
Yeah, it's orange. The options here, I'm guessing.
All right. Well, let's see if that fixes our problems. Oh, it did. So we're writing this result.key to the intermediate reduced file name.
Cool.
Panic. Too many open files.
Yeah.
All right. Well, without knowing a great deal about Go's file handling, we can probably make a safe assumption that we need to move opening of the intermediate reduced file name outside of the for loop. However, every iteration of the for loop, it might have a different intermediate reduce file name.
Yeah, I think for right now, let's just not do defer f.close. Let's just f.close at the end of this block.
Okay, let's give that a try.
One up.
Oh, here?
Yep, and not defer. Just do f.close.
Oh, okay. I'll keep it there, so we've got it. I think this is some type of asynchronous, I mean, this is some error handling. So yeah. My understanding of Go is that if you have some kind of exception in running write string, for example, errors actually are not automatically propagated up your stack.
Yep.
You need to explicitly say, if an error occurs, meaning error is not nil, meaning that there's a second return value of write string.
Right.
Then, yeah, you got to manually do this.
Yeah.
Which seems jank as F. All right, let's try running the test again.
It's very hard to abstract things, I think.
You're right. That worked. Cool. So we got to the end, and then we tried in our merge step, we tried opening the intermediate file that we've ostensibly been writing to.
Okay.
And it says no such file or directory.
We tried to open up a different file. We tried to open up mrtemp test dash.
Oh, res-0 as opposed to 0-0.
Yeah.
So after the map step, we have our map task number.
Yep.
And then we have our reduce task number. And in the merge step, we just need reduce file names. So merge happens after map and reduce have happened.
Yep.
So it looks like we were doing pretty well, and we just need to write our reduce step. Is that fair?
Yeah, I don't know where phase merge happens.
We'll walk up the stack from where we were implementing our do map function.
Okay.
We can probably walk to it from our test. So we are running a sequential test. Our replicate. I think it was probably this test that's failing. Does it say? Does it even tell us what tests we're failing? It just says test failed, 7 seconds. It doesn't even tell us what test.
There's got to be a test somewhere printed out.
Maybe at the very beginning. Well, what we can do right now is we could take out a lot of our print statements since we are pretty much finished with, I believe, hopefully, we'll take out a bunch of print statements. We'll also take out this print statement. We can probably also take out the file name that we've written to.
Okay.
We can just comment it out. What we can do here is we can say to do append JSON, use JSON instead of passing through the key. Whoa. But yeah, I think we're good here. We can take out this print statement as well. Let's try running the test again.
Okay.
Cool. Imported and not used. Okay. Well, let's comment out. So we still got a print statement somewhere, but yeah, test is still failing. So if we want to see, I mean, we could redirect this to this output to file and then look at the top of the file to see if at the top of this output that we're seeing, which is very long, the name of our failing test is. But we could also try just walking the stack.
Yeah, let's just try one.
Do you have any ideas about how to walk the stack? Because I really do not. We were editing the common map file. So here's our test file where we have that these sequential tests that we're trying to run. So I think there's only 2 sequential tests. So my guess is that this one is failing. Just
yes, I guess we could start walking through sequential.
So because I'm not using an IDE and I'm super dumb about it, I need to find just guessing what files sequential is in. So let's set no wrap. So this is the main driver for the MapReduce tasks. And it's called sequential because it does not run them or run them in parallel processes. So it just runs everything linearly. So yeah, this is probably what's calling do map. We're done with the do map phase. We can write the do reduce. And my guess is if do map is defined in common map, do reduce is probably defined in common reduce.
Yeah, what was the error that we got?
The error was failing to open this file.
So that's during phase merge.
Yeah. I think this was also a logging statement we added, but that was before we knew how to write log statements that added new lines after them.
Yeah.
We can try looking for merge phase. Oh, there we go. That might be not us. We might have written that. Yeah.
Merge phase?
Yeah.
I don't think we wrote merge phase. But I think this is either happening before or after. So it's trying to read the results, which we haven't written yet, probably because we didn't implement the reducer yet.
Yeah, totally. So we were looking at common map before implementing the do map method. Now we just need to implement the do reduce method.
I think so, yeah.
So this is the whole file. Not bad. Most of it's their documentation strings trying to give us guidance about how to write this. Are you able to see okay?
Okay.
I realize the font color is kind of rough.
Yeah, it looks good.
So do reduce manages one reduce task. It reads the intermediate key and value pairs produced by the map phase for this task and sorts the intermediate key value pairs by key. Okay. Calls the user-defined reduce function, reduce f, which is provided to us for each key, and writes the output to disk. So it seems like the do reduce does not utilize the value at all. Like values. All right, well, let's read the rest of this documentation string.
Right, so manages one reduce task. It reads the intermediate key value pairs. For each. Okay. Yeah, so I think, so it's going to have to read the file that it's given, get all the keys that are the same, and then pass an array of all the values for those keys to the reduce function. Does that make sense?
Come again?
So this file needs to open up the file, or this function needs to open up the file, the intermediate file, get all of the values for a given key, and then pass the key and the values, an array of values, to the user-defined reduce f function. And then that reduce function will do whatever it wants.
Whoa.
The length.
Okay.
I think.
Yeah. No, that sounds right. So we have this reduce name function. So we're gonna want to, God, how do we? So we got this reduce name. It's gonna take a job name m, which not sure exactly what that variable is, and reduce task number. So first and third arguments, pretty straightforward. They're up here.
Yep.
I
need to read one.
Oh, so it's the map task name. So I think we're gonna need to basically do a for m in range of nmap kind of thing.
Oh, okay.
So we're going to get f names or file names for each of the for n where for m well, for nmap where nmap is the number of map tasks.
Yeah, that makes sense.
So we're going to do a bunch of garbage in this loop. Do reduce is basically where the magic will happen. Yeah. Or reduce f, which is the user-defined reduce function.
You could print some of these variables out just to see what is going
on. Oh, for sure. Print ln f name. We're going to need to import funct. And I am not that used to, I'm definitely not used to going. This stuff's whack. I don't think I wrote this range.
Once you start getting it, kind of makes sense.
Yeah, for sure. Let's see example of how to do the range. Here we go. That was pretty close. We need to do a colon equal though. Is the only difference for how to do a for loop.
Yep.
Well, nmap is just an integer, where in common map where we're doing a for loop, results is a list or array or slice or whatever Going's array data structure is. So I'm sure you know Ruby, Python, there's an easy way to create an iterator, much like a list, that is like the range of numbers between 0 and nmap.
Yeah.
So we're going to need to look that up first. Golang range of int. Yeah. Does this go? Oh, okay. We can just do this. This looks very C++ or C.
Oh, great.
So instead of using the range global, we can just say I less than nmap.
Okay. Yeah, that works too.
So instead of using m, or we can replace I with m if we want to stay consistent with our variable name. We'll give this a shot.
Yeah, does m need to start at 0?
Ooh, yeah. Oops. For sure. And it should be n less than that.
There we go.
Cool, let's give it a shot. This is writing to the files and whatnot.
Yep.
So it looks like it's trying to, we are printing the file name here where we were not before.
Okay.
But we're not doing any reduce yet, so we're not outputting to any file that just has the reduce component right here. Yeah. So
actually, you know what we were probably doing?
What?
In our map function, we're opening it up in append mode, right?
Yeah. I'll open that up.
So every time we run this test, are we continually adding input to those files?
Ooh, yes. We need some kind of cleanup.
Yeah, I think that's why it's taking longer and longer each time.
Shit, you're totally right. Maybe that's talked about. Let's take another longer look at now that we have a lot more context about things.
Yeah.
They might have some recommendations about how. In fact, maybe their code does cleanup for us, potentially.
Oh, like deletes the files for us?
Yeah.
I mean, that might be possible as well.
Because they definitely clean up. I think it ought, in the tests, when we looked at them last week, yeah, they make a test input file. And that input file gets overwritten.
Well, can you just ls in the directory and see if those files are there?
So this one is, yes, it is here. We can look at how many lines it is. Oh, it's 0 lines. So yeah, I would guess that, yeah. Whoa! 0 lines, my ass.
Yeah.
Oh, you know what we're definitely not doing in our
adding a new line for sure.
Yeah, shiza. So there's this write string, but there's probably a write line method, which will add the new line for us. Let's check that out, and we'll run the test twice,
yep.
And we'll see if it does what you're suggesting might be going on. Good catch, dude. Golang write line. Not buff.io. We're using OS, or we're using a file object, which is part of the OS package. So these first few results are not very attractive. We shouldn't have to use a third-party library to, or just, yeah. But sure, let's check it out. Write lines. No, read lines. This is for doing lines in batch. Yeah, this is using buff.io, a buffer input output.
Yeah.
So yeah, they're explicitly creating the file each time. Writing, geez Louise. We can just add, we can probably
add like a string at the end there. Yeah.
Yeah.
Let's try that.
I think it's a, I think you can just you can pass it an arbitrary number of arguments.
Yeah.
Before we do, let's check that out. Write string. It takes just a string. So what I'm doing right here might be wrong. We might need to do like plus or something. Let's do plus. Let's see if that works. Go run, go test dash run sequential. Okay, same error. Let's see whether this file now has a bunch of lines. It does, well, yeah, now it has a lot of lines. So let's try running it again and see whether the number of lines increases. So that's like 10,000 or something. So it should be 20,000 now. Or I think it's 100,000. So yeah, you're totally right.
Well, I guess
second. Maybe there's a cleanup that we can look for. Yeah, cleanup. Wow, that was lucky. So maybe there's a cleanup step that we can hijack. That'll clean up our files for us.
Yeah, so there is a cleanup files method.
And it takes a MapReducer object, and which has a cleanup files method.
mr.files.
Let's look. So I think it was sequential is defined in master. There's a cleanup files, and like you were pointing out, looks like there's a files attribute of the MapReducers.
Yeah.
Looks like here's a reference to the MapReducers files. So it looks like sequential is a constructor for a class. And so the return value is a MapReducer MR variable, type master, whatever that means.
Okay.
So how it would be, or where it would be setting or specifying its files attribute, whew, not sure. But yeah, if we can add the intermediate files that we're creating in our map and reduce,
yeah,
and like you're pointing out, we should be able to clean up files automatically.
Yeah.
So here we loop over our MapReducers files. So I'm guessing
input files. I'm guessing
when new master is this function that returns a master object, and the master object is probably what has these auto-generated test input files.
Okay.
And so maybe we could add to its files attribute, but I think we're effing with the wrong stuff.
Yeah. We should just remove the file manually for now, and then.
Yeah, or when we first open it, we at the beginning of our do map, if it has length 0, basically before our for loop, clean up old files.
Yeah, something like that.
However, we don't know what the file names are until we get into the for loop.
Yeah.
Oh, God damn it.
And we always want to append within this for loop. Just, I don't know.
Well,
we have to
we basically know that there's going to be n files. And so we can say for I equals 0, I less than n reduce. Basically, we can loop over all the potential file names. So do a double loop. Jeez. So remember the intermediate reduce files that we've got have this name with the map task number and the reduce target.
I mean, you could just copy what we've done.
We can say
for result and range results, and then get the file name again.
I think that's it. I think this is just what we need to do to clean up old files so that they're empty before we start adding our current map to it. Does that make sense?
Yep.
Okay. how to empty a file really quickly and go like file. Is there a better Google search I can do?
No, I don't know. Delete a file?
Good idea. That seems pretty straightforward. Delete. Oh my God, not there. Delete a file. Jesus. How do they not have results for Golang delete file?
I don't know.
Clear file. I hate looking at gists. They're so horrible.
OS.
Oh, there we go. So this will silently try and remove the file, whether it exists or not.
Yep.
Cool. So in our case, yep. That look good?
Sure.
We can straight up link to this. We need to come back to it. Oops. I'm sure this would not get us brownie points from the TAs on the distributed systems course, is to include links to frickin' Stack Overflow and stuff, but whatever. All right, so what we're doing here is we're making sure that we've nuked the intermediate reduce files before we start trying to append our stuff to them. So let's check, see how many lines MR temp has, the intermediate file has.
Yep.
And we'll run our tests again. Awesome. Undefined I. Need a colon here, right here, I'm guessing.
Yep.
Is error. So what is, is error is just, whoever wrote this just thought they would be clever.
I don't think we need that.
Yeah, we don't need that. Well, we do want to handle panic, I think. So looks like
just panic error.
Yeah, we don't need to print error, right?
Yeah, just like we do with the other errors. Yeah.
Oh yeah, like down here. Cool. The other thing we can do, we don't need to var error. We can just call an equal like we do down here.
Yep.
Okay, cool. Let's give this another shot. So again, the word count of our intermediate file is 200,000 lines. Oh, so we can do go test run sequential. Cool. Looking good so far.
Looking good, yeah.
Same error. Cool. We're back to 100,000 lines. So if we run it one more time, should work fine. Okay. Cool. Okay. So now that we caught, thankfully you pointed out this problem, which could have caused us a ton of grief. Let's go back to implementing the reduce step.
Okay.
You will need to write this function. No kidding. You'll need to read one intermediate file from each map task. We'll call a reduce name, and then the job name, and then M, and the reduce task number to yield the file name from map task M. So we know how many map tasks there were, and we're just iterating over them to come up with the intermediate file names that are to be performed by this instance of the reducer.
Yep.
So in our test output, this is the intermediate file that our reducer, our single reducer, is trying to read. So that's line 26, right?
Did we print F name?
Yeah, line 26.
Okay.
So that's what's shown up right here.
Okay.
So now, okay, let's read more about this. Your do-map function encoded the key value pairs in the intermediate files, so you will need to decode them. In our case, we were just writing the raw result.key. So if you use JSON, which we didn't, you can read and decode it by creating a decoder and repeatedly calling .decode ampersand kv on it until it returns an error. You may find the first example in the Golang sort package documentation useful. Interesting. Okay. Reduce F is the application's reduce function. You should call it once per distinct key with a slice of all the values for that key. So we're definitely going to need to modify our mapper, our do map, to pass both the key and values.
Yep.
As JSON probably is the most sense. Reduce F returns the reduced value for that key. You should write the reduce output as JSON encoded key value objects to the file named outfile. So they want us to do JSON anyways, so yeah, we should do JSON.
Yep.
You should write the reduce output as JSON encoded key value objects to the file named outfile. We require you to use JSON because that is what the merger then combines the output from all the reduced tasks expects. There's nothing special about JSON. It is just the marshalling format we chose to use. Your output code will look something like this. Okay, yeah, that makes sense.
Yep.
Any idea why they call it marshalling? I mean, I think both of us are familiar with marshalling, but marshalling data. In computer science, marshalling is the process of transforming the memory representation of an object to a data format suitable for storage or transmission. Yeah, like serialization or deserialization. So yeah, this is a piece of vocabulary that I don't think either of us really use that often. Is that fair to say?
Yeah, marshalling.
Yeah, we talk about serializing and deserializing.
Definitely serializing is more common. I think they're the same thing, except it looked like there was a subtle difference at the bottom.
Okay. Said comparison with serialization. To serialize an object means to convert its state into a byte stream.
You stop sharing your screen.
Oh shit, my bad. I think my mouse is running out of batteries. The term Marshall is considered to be synonymous with serialize in the Python standard library, but the terms are not synonymous in the Java-related RFC law.
Okay.
Okay, so it's just like what the intermediate format is.
Yeah.
That's super, okay, great. Okay. So we may need to go back again to our do map function and change what we're writing to our intermediate files. Shall we?
Yep.
Writing
JSON, I guess.
Yeah. So I'll close the do reduce stuff for now. We'll go back to the go map. So here's where we're writing our line, or appending lines to our intermediate reduce file.
And so there's a comment down there about JSON.
Oh my God, they're so helpful. So instead of just writing the result.key, let's read it. So mapf is the map function provided by the application. Yep. The first argument should be the input file name. Yep. Though the map function typically ignores it. The second argument should be the entire input file contents. Yep. Mapf returns a slice containing the key value pairs for reduce. Yep, that's what we're handling. We're looping over the results. Look at Go's IO util and OS packages for functions to read and write files. Coming up with a scheme for how to format the key value pairs on disk can be tricky, especially when taking into account that both keys and values could contain new lines, quotes, and any other character you can think of. Yeah, that is super annoying. Yep. One format often used for serializing data to a byte stream at the other end can correctly reconstruct is JSON. We're not required to use JSON, but as the output of the reduced tasks must be JSON, familiarizing yourself with it here may prove useful. Okay. You can write out a data structure as a JSON string to a file using the commented code below. The corresponding decoding functions can be found in commonreduce.go. Remember to close the file after you've written all the values. Fair enough. Cool.
Okay.
So the ... here is what's a little confusing.
Yeah, I'm not sure if that's like their pseudocode commenting or just that's how we should be using it.
Well, I think this is our F in this context. We can be more explicit and call this file. I mean, we're going to replace these 3 lines anyways. But rather than looping over the keys and values, what we're going to do is just write result.
Yep.
Because each result should be
I think that would work. I don't really know.
Well, the fact that the new encoder takes a file suggests that it might be handling the writing of rows or lines to the file for us. So these lines are no longer necessary.
Yep. So we can comment those out.
However, let's look up, another thing we're going to need to do is import JSON probably. So now that we're importing JSON, let's take a real quick look at the official Golang docs about JSON.
Okay.
And about encoder objects, decoder objects. Encode writes the JSON, encoding a V to the stream, followed by a new line character. Awesome. That's what I was curious about, is whether we needed to write
a new one.
Yeah. So we can just straight up get rid of that. And I think we should be good.
Yep.
Let me see if I've fucked up our tabs and spaces. I have. Yeah, there we go. I started using
my Go format. I don't know.
I have a mix of, we have a mix of tabs and spaces. It looks like the source code that they gave us uses tabs and not spaces. So I'm just trying to stay consistent.
Yeah.
I think the default I have set for Vim is to use spaces for tabs. So when I hit tab,
space again.
Should smartly figure it out. But let's try running our tests now. I mean, I think our reduce function should now. No, our reduce function should work fine. It's just we're not doing any reading from our intermediate reduce.
Yep.
Or whatever. Shall I run go test? Cannot find package JSON.
JSON.
Whoa. Okay. Maybe we don't need to import it. Maybe JSON is just this built-in global.
Yeah.
That would be weird, right?
That would be kind of weird. Oh, it's
this?
import encoding JSON, maybe.
Ah, bingo. Genius. You're a freaking genius, man. Getting closer. No new variables on left side. That's line 79.
I'm gonna find key value.
Ah, this needs to be your result. $79. What do we do on 79?
Oh, are we defining?
Oh, we're overriding error. How
are you supposed to do that?
We can probably, well, let's look at what encode.
Actually, maybe just take out the colon.
Oh, good idea. Because we already are defining error up above here.
Yeah.
We should probably do something smart like what they're doing up there, which is setting error semicolon. If error not equal nil, then we should probably panic. Let's try that. Or, I mean, this probably won't save us anything at this moment in time, but
you need an if statement.
An if statement? Oh. So encode the function returns an error. Cool. So that should work. We should have the function signature, right, for calling encode. This is all stuff that they didn't provide us down here, but we know what to do, I guess. Thank God. we could change this to a variable name of KV like they have down there, but let's not.
Make result makes sense.
Undefined variable f on line 86. Ah, I'm a dumbass. I tried being smart and making it more explicit. Cool. Okay, so let's check real quick to see whether the intermediate file now is JSON. It does.
Okay.
Cool. So now when we go back over to com and reduce, we can now, what we're going to do is we're going to read from fame, read lines from fame for line in open fame. We're gonna reduce, and then with the results of reduce, those are going to be written to our file that's handled by the merger.
Yep.
So in looping over each line, we're now going to need to JSON.decode or whatever. Yeah.
Yep.
So actually, in the same way that calling the encode method of an encoder object adds a new line automatically, decode may automatically read line by line. Yep, it reads the next JSON encoded value from its input and stores it in the value pointed to by v. Oh, cool. Example.
Oh, perfect.
Oh my God, this is intense. Or at least feels intense. JSON.new decoder. Interesting that there's a new decoder method, but there's not a new, oh, there's a new encoder method. So I'm wondering what's the difference between instantiating an encoder like we did in our common map and calling new encoder. It looks like they use new encoder down here. What the H? All right, let's read this again.
What did we do?
In our common map file, when we encoded our stuff as, oh, we did call it new encoder.
New encoder.
Oh, never mind. I'm an idiot. So here they're giving an example of.
So this is outputting the results of this function, not reading it.
Ah, yeah. So we've got it up here, or we started to do this.
Yeah. So now we have to figure out how to decode this data.
Yeah. So we're going to call new decoder. And new decoder takes an IO reader, which is probably a file. So we're probably going to need to create a file, right? os.open fname. And it's fine if it's just in read-only mode.
Yep.
And so we're going to, well, we don't even need to do the for loop there. New decoder takes the f. I'm missing a lot probably right here. We're going to need to also import os.
So under decoder, it looks like there's a example.
Oh yeah, my bad. So new decoder, although they're not handling specifically a file.
Yeah, look at the example under decoder. I think it's up. Yeah.
Ah, here.
So that's what our JSON stream looks like.
Oh, genius. So instead of doing nothing, instead of just printing, we'll be calling reduce f. We can call m.key, m.value, right?
Yep.
What is this message?
Yeah, so our message is going to be the value object. Yep.
So the key value data structure, I think, is defined in master. Or we can grep for key value. So looks like key value is defined.
Common.go.
Common.go? Okay. Yeah, so it's this type definition that's a structured data type. Yep. So we're defining a custom data type that has only 2 keys. Cool. So unlike other languages that you and I are probably used to, key value is just available in the namespace of this file by virtue of sharing the package name at the top of this file.
Yep.
That's something I find super confusing about Go, is that it's not super explicit what is being brought into the namespace of your various files that you work on.
Yeah.
And that in turn is super annoying, in my opinion. So we need to get a decoder variable. Yep. We're probably going to need to fix how we're going about opening this file. So let's take a look at the common map to see how we open a file. Go again. os.file, and we can open it in read only. Is probably the mode.
I think we could just do IO util read file.
Is that what's preferable for the decoder?
I'm not sure. It's just the example in their decoder sends in just a raw string of JSON and not a file.
New decoder takes a reader.
Oh, an IO reader. Okay, then yeah.
And that is probably a variety of different types.
Yeah, I'm guessing file implements IO reader.
So we open the file down here. God, even familiarizing ourselves with opening a file is brutal. Oh my God. All right, so it doesn't look like you need to provide these second and third arguments to open file. Yeah. So I'll just get rid of them. Okay, so now we have a file object. We should probably pass file to the new decoder. So we're going to be reading out the intermediate file here.
Yep.
Shall I try running the tests before we try invoking the reduce function?
Works.
Okay. Go test dash run sequential. Undefined JSON. Undefined IO too. Encoding JSON. Is that right?
Yeah, encoding JSON.
Yeah.
Where are we using IO? Oh, IO in the file.
And log. Where's the log? Well, we don't want a log. We just want a panic, right?
Yeah.
So panic is a global. We don't need to import anything. Not enough arguments. So they don't even, if you say open file, then you need to specify a bunch of other arguments. So we'll just say open. Was there another error? Imported and not used.
IO. I think you just got to import IO.
Yeah. And there was one other error, it looked like. Oh, undefined IO. All right, let's run go test again. Error declared and not used, line 31. Okay, so I think we can underscore, or we can mimic what we do in common map, which is if there's an error opening the file, then panic.
Yeah.
We'll just mimic that. We'll actually use the error variable. We do a redefinition of error again down here. So now we're probably going to get an error, so you're going to need to do that, right? We're going to need to get rid of the colon since it's not, we're not declaring a new variable.
I think so.
That's super annoying. Oh my God, what an annoying language.
Yeah.
All right, let's run. Cool. So we should print out our JSON now, reading the intermediate JSON file. Cool. Great.
That's good.
So the reason there's no value after the colon is because there's no values for this map function or this problem that we're working on. Dude, I'm feeling pretty good so far. We're almost done with getting the sequential tests to pass. I think the point of a distributed systems course is to get to solving the parallel tests.
Yeah, to parallelizing this.
Let's take a look at what, really quick reading ahead at what the run-on problems are. So we're going to actually have to define our own map and reduce functions to do stuff like counting words.
Yep.
That doesn't sound very hard relative to what we're doing right now.
And then probably work on distributing the tasks.
Yep. So like we're doing right now, where we're running, we're saying only run tests that have sequential in their name. We're going to need to start figuring out how to get the non-sequential tests to pass.
Yep.
And this is going to probably be using some pretty intense Golang features. Intense might be an exaggeration, but for the purposes of a live stream, this might be intense.
Using RPC, we're gonna have to. Oh, there's a bunch of hints.
Oh man, and handling worker failures. So if like one of our files doesn't work, how to reallocate it to another worker process. Extra credit. Creating an index. Woo.
All right.
Well, let's finish this first part of lab. I think we're probably within 15, 20 minutes of finishing this first part of the lab.
Yeah.
I think that's fair to say.
Yeah.
Okay, so
we're
going to read one intermediate file from each map task.
Yep.
Which we're doing. And our do map encodes, while our do map encoded the key value pairs in the intermediate files, we will need to decode them, which we've done.
Yep.
If you use JSON, we can read and decode by creating a decoder and repeatedly calling .decode. Sick. On it until it returns an error. So it'll return an error on line 42 when we're done reading values out of the file.
No.
There's probably something smart that we'll need to do to catch that error.
No, so on line 40, it catches the end of file error, and it just breaks.
Oh, perfect. So then once we're done reading the file, we'll continue on our merry way down here.
Yep.
Awesome. Reduce F. Okay, you may find the first example in the sort package documentation useful. Interesting, because we may have to sort the results, I'm guessing.
I think we need to sort the, well, I'm not sure what. Let me see. I don't know. Let's look at that example, I guess.
Got it up here. It looks pretty straightforward. So I think before writing to the output of our reduce task, we will need to sort the results. So reduce F, which is the user-defined reduce function, is the application's reduce function. We should call it once per distinct key. So what we're going to need to do is build up a data structure that keeps track of each key and array of values.
Yep.
So even though the values in this particular MapReduce task that our test is running has values of null, we're still going to build up an array of length n for the number of map tasks or map outputs for a given key.
Yeah,
so
start doing that.
Yeah, so we're going to need to make some hash map, and then we're going to need to say we're going to need to append values to this hash map, and then we're going to say for key in our hash map, we're basically going to need to
Pass that to our
do something. Yeah.
Okay.
Something along the lines of what I was just showing. So the reduce, we need to write the reduce output as JSON encoded key value objects to the file named outfile. Sorry, I skipped this paragraph. This is where we're at right now. You should call it once per distinct key with a slice of all the values for that key. So slice, array, list, kind of the same thing.
Yep.
Reduce F returns the reduced value for that key. Okay. What does reduce F take as a function? It takes a string and a list of values.
Yep.
So we're going to be calling reduce F down here on the key and the hash maps list of values for that key. This is all pseudocode I'm writing right now, for sure.
Yeah, the question is, how do we get D to work? Like, is there something special that we need to have for D to be a hash of strings with arrays of values?
For sure. Yeah. So I'm guessing it'll be a, Golang hash map data structure or dictionary. This is what a lot of people.
So we want
maps. Oh, there we go. Map as a key type, which in our case is a string, and then a value type, which in our case I think is a list of integers.
Yep.
Or slice of integers, however they would call them. Oh, God.
This example on this page? String.
Oh, here we go. Kind of. Here's a list of data type. So this is very similar to what we're going for, which is a hash map which is keys or strings, and then its values are a list of persons. In our case, it's a list of integers, I think.
Okay.
Does that make sense?
Yep.
So I'm calling it data, which is probably not very descriptive, but you see where I'm going?
Yeah. Go back to the example. So I think we need like var data.
Or yeah.
No, sorry, go back to the example. What is that make function?
Whew, I don't know.
All right, well, let's try wrapping that in make.
Oh, this is actually not the official docs. This is the Golang blog from 4 years ago.
Okay.
Map types are reference types. Okay. So the value of m up here is nil. It doesn't point to an initialized map yet. So a nil map behaves like an empty map when reading, but attempts to write to a nil map will cause a runtime panic. Don't do that. To initialize the map, use the built-in make function. Cool.
Got it. So we do need to use make, I think.
Yeah. However, it doesn't look like it uses var.
Yes.
Yeah?
Yeah. Maybe colon equals?
Let's see their longer example down here. Yeah, you're right, colon equals. Cool. So we'll call this reduced data because this is where we're collecting the reduced data, or the data to be passed to reduce. Do you have a better name for this, I guess?
Reduced data is fine.
So it's the keys and lists of values associated with those keys that we're going to be passing into reduce f.
Yep.
And whatever the return value is of reduce f, this needs to be written to the out file.
Yeah.
Somehow.
Yeah. Maybe let's just log that return value.
Okay. We don't need to add a new line ourselves, right? I don't think this is the right append. Let's take a look real quick here at the example of the map that has keys of strings and values of lists of persons or slices of persons.
Okay.
So it looks like there's a global called append, which takes a slice and the value you want to append to the slice.
Okay.
And we're going to overwrite reduce data's key at that point.
Yeah.
So we actually are pretty close. We just need to say append reduce data m.key with m.value.
Yep. And then don't set that as reduced data.
How's that? Wait, where?
You're setting reduced data m.key as a result of the append.
Oh no, that is correct.
That is how you do it.
Yeah.
The example. Oh, I see. Okay.
So we're overwriting the contents of the slice that the given key is set to.
Yep.
With a list that now includes p at the end.
Gotcha.
So I think we're good. Let's so this is definitely not the for loop for looping over a map.
But the example over there, like for L, I think that's what we need to do.
Where do you see it?
Like
oh, here?
Yeah.
We're looping over p.likes, which is the likes of a given person.
Right, but in our case, we need to loop over the
map, right? Going loop over map. K comma v colon range. Yeah.
Yep.
Yeah.
I think so.
So I'm not sure if I've got the signature of reduce F right. So let's take a quick look back at reduce F. Yeah, it takes a string and an array of string values.
Yep.
Ah, so I was wrong here about the values being int, they are strings.
Oh, correct, yes.
Otherwise, we should be good. Yeah.
Yeah.
Let's try running our tests again.
Yeah, let's do it.
Cannot use m.value type string as type string in append. So we might need to dereference m.value.
Okay.
My familiarity with what dereferencing means in Go, though.
Maybe we don't need a star string or data type.
On line 47.
Line 30.
What do you mean here?
Yeah.
Well, let's go back and look at what this was doing. A Go map type looks like this, where key type may be any that is comparable or comparable, and value type may be any type at all, including another map.
Yeah.
So map types are reference types, like pointers or slices, and so the value of m is nil, and so that we got to do the make.
Yep.
So
like
go ahead.
For example, they don't have star int there.
Where at?
Yeah, so like they have just map string int. I think if we just did map string string.
Well, the key here is that this map is between strings and integers.
Yep.
While we are between strings and slices of strings.
Slices of strings, got it.
So we may need that asterisk, but we may need to do something like dereferencing. So m.value is a pointer to a value, perhaps.
I see.
Or sorry, let me correct myself there. What I mean is the error we're getting is that on line 47 and 51, we have the wrong type.
Yep.
We have a type string as opposed to a pointer to string in append. So we may want a pointer to m.value.
Okay.
On line 47 and then line 51 too. We might need it to pointer or dereference or something. I'm not positive about that yet, and it's just my suspicion. I don't think we need to remove the star though here. This really requires knowing more about going slices. Scheiße. Here, there's no asterisk declaring a slice. Woo. So slices are arrays of fixed size. So the reason why we probably need the asterisk is because it's an array of arbitrary size, right?
I don't know. Let's just try taking the asterisk out.
Okay. I'll try running the test again. Hey, you're freaking right. Oh my God, you're totally right. Okay.
Did it work?
Yeah. Yeah.
Okay.
It's printing the key value, the return value of calling reduce on the key and its values.
Okay, cool.
Sweet. Your do map, okay, so you should write the reduce output as JSON. All right, let's actually start here. Reduce F is the application's reduce function. You should call it once per distinct key, which we're doing, with a slice of all the values for that key. Perfect. Reduce F returns the reduce value for that key. Makes sense?
Okay.
You should write the reduce output as JSON encoded key value objects to the file named outfile. Okay.
Okay.
We require to use JSON because that is what the merger then combines output from all the reduced tasks expects. There's nothing special about JSON. It is just the marshalling format we chose to use. Your output code will look something like this. All right, let's just freaking copy that. So we're probably going to want to do this once. We'll do this once per map task. Yeah. Is that fair?
Once per map.
At the very end.
Yeah.
I'm not positive. Since we only have one out file, I think we do want to do it at the very end. Yeah. In fact, our reduce data is going to be invariant of which reduce tasks are or which map tasks are reducers handling.
Yep.
I had to move it outside the for loop for sure. And then similarly, writing output is going to happen last too. And similarly, for auditing, logging purposes, we can move this outside the for loop too.
So in map is the number of map tasks. Okay.
So we actually have already written this for loop here, and that's the for loop that's going to be writing results into the out file.
Okay.
So we have an out file up here. It's the name of it's a file name.
Okay.
So again, we're going to need to open it.
Okay.
So much fun. And this is another intermediate file that we might need to wipe.
Yeah.
Right. So
this is the reduce. Yeah. So this is the output. We're going to need to wipe it.
So I'll copy what we're doing at the top of our map function and do similar here. I'll add a print statement just for sanity. Clearing contents of out file. Yeah. We don't want to read the file though. Whoa. Where do we nuke the contents of the file? Here. Sorry, I did that wrong. And then we're going to need to open it down here on line 63 in the same way we open it right here.
So we need to open the out file.
We probably shouldn't call it out file. We should probably call it file because the name of the file is out file. So once we've cleared the file and opened the file for writing, we're going to loop over the keys and values of reduce data. And we're going to call reduce F on the keys and values. And we're going to write those to the out file. Yep. Or in our case, it's now called file. So we can pretty much just copy paste this here and say key. Oh, yep. Awesome. So they even do it inline. So we can replace here with the return value.
Yep.
Cool. I think we're good.
All right.
Let me add a print line here saying reduce results written to out file. Yeah.
Okay.
Other than that, I think we are done.
Yeah,
let's try running the tests. It's probably going to throw some type safety error. Yeah, undefined name. Oops. Yeah, this should definitely be out file. Cool. Cool.
All right. Let's see.
Oh, no such file or directory. So we, if it's not there, we should fail silently. Yeah?
Yeah.
So if error not equal nil.
Yeah, there's probably some way that we can do like if the error is not a.
Do not worry. Yeah, if the file exists, remove it. You know, I'll probably even remove that println once we've confirmed that.
Yeah.
The reason it wasn't an issue before in DoMap is that we had already created a file previously. Ooh, so close.
That's a file or directory.
We're still getting a panic, and the panic doesn't tell us what line. Yeah.
Yeah.
I guess in DoMap or Common Map, line 54. Yeah.
Know. So this is remove file test 00. That's, I don't think.
Oh, it's here in our DoMap that we're getting problems. Let's ignore the problem.
What? Maybe.
Oh yeah, it's the same problem. It's the same problem before.
Maybe it's because our program's going far enough now that the cleanup phase is working.
Yep, and we're going to a second test. So I think we're passing one test and failing the second. Undefined. All right, I'm just going to remove the printlns when we're trying to remove files that don't exist. Oh, this is getting close. Oh, that looks like one test passed.
Okay, so one test passed.
Oh my God. Dude.
That's fast.
Sweet, man. All right. What I'll do before I totally F us up is I will add this to the Git repo and create a pull request. Lab 1, part 1. I think I might need to make a forked copy of your Git repo since I probably am not a collaborator on it. So if I try pushing to your repo. Okay.
Let me add you.
Am I doing that? So complete lab 1, part 1 to run these tests. I believe it's we run go test run sequential. So we've only completed the part of this lab that has tests that run sequentially. Am I a collaborator?
Yeah, you're a collaborator, but you need to accept the invite.
Okay, I'll do that from my phone real quick. I'll try pushing, but yeah. Oh, got an email. I'll do this real quick. I'll take off screen share for a second. We can just chat. I don't know. How are we doing so far?
I think we're doing good.
Do you want to drive now that I pushed up the code?
No, I'm good.
Oh, you sure, man?
Yeah, maybe next week.
Man, we've been going for hour 45 now.
Yeah.
Let me accept the invite on my laptop because this is heinous on my phone. Yeah, we're not really doing any of the distributed stuff yet. I mean, we are figuring out Go.
Definitely, this is an exercise in learning Go as much as distributed systems.
Nothing is super mind-blowing yet. Like, I mean, the data structures of Go are things both of us are learning right now.
Yeah.
But distributed systems-wise, nothing crazy going on. So I just submitted you a pull request on the Git repo. Let's take a look at part 2 of the lab.
Okay.
And see kind of just what kind of effort it looks like. We can try running the distributed tests and see whether where it might fail with those distributed tests.
Okay.
Yeah, I'm screen sharing. Can you see my screen okay? Ben?
Yep, I can see it.
Cool. So part one, MapReduce input and output. We freaking crushed it, bro.
That one, easy.
We can definitely remove a lot of the print statements, which are probably a slowing factor in the tests because they're printing a ton.
Yep.
Part two actually sounds really easy. We're going to be providing text files, and we're going to be reading in those text files and splitting up all the words, and then we're going to be finding like the most frequently said words in these text documents.
Yep.
Dude, I think this is going to be pretty easy. You want to see if we can just crush this out in 10 minutes, or?
Let's give it a shot.
Okay. So you will implement word count, a simple MapReduce example. Look in main/wc.go. You will find empty mapf and reducef functions. Your job is to insert code so that wc.go reports the number of occurrences of each word in its input. Word is any contiguous sequence of letters as determined by unicode.isLetter. Oh, okay. Okay, so we're going to be doing the parsing out of words. Okay. There are some input files with path names of the form pg-star.txt in the main folder of our lab, downloaded from Project Gutenberg, which is a cool website which has books for free. Here's how to run wc, which is the word count. Actually, there's a utility in Linux we've got right now. I was using it to get the line numbers. But we're in the MapReduce directory, and these things they're telling us about are under main. So if we go to main, there's a bunch of data txt files mentioning all the PG ones. So pg-star.txt, do a list. So yeah, here are all these Project Gutenberg input files. You can see how this could get really large.
Yep.
Here's how to run wc with input files. Let's give that a try. So we're going to cd into the main directory wherever we are. And then we're going to try running go run wc.go. So there's a wc.go file here, like they say, that doesn't do anything yet.
Yeah.
Try running it. It's going to say missing return. Cool. Exactly. Review section 2. Oh man, I don't know if we're going to do that. Your mapf and reducef functions will differ a bit from those in the paper's section 2.1. Your mapf will be passed the name of a file, as well as that file's contents. It should split the contents into words and return a Go slice of MapReduce.keyValue. Okay, so it should return basically a list of keys and values, where key is probably the word and value is probably empty. While you can choose what to put, in the keys and values of the mapf for the mapf output, for word count, it only makes sense to use words as the keys. Your reducef will be called once for each key, with a slice of all the values generated by mapf for that key. Yep, it must return a string containing the total number of occurrences of the key.
All right.
Oh man, there's a lot of extracurricular reading here. That's probably a prerequisite, but we can freaking sling code and see whether we can do this on our own.
We'll figure this out.
Yeah, they give us a pretty big hint by using unicode.isLetter to iterate over all of the characters of the input to identify when there's words or where there's white space.
Yep.
Okay, so we're really just going to be filling in the contents of this 147-line wc.go file.
Okay.
All right, so the map function is called once for each file of input. The first argument is the name of the input file, and the second is the file's complete contents. So yeah, we're going to be making a variable or a map.
Yep.
Let's look at our common, in our MapReduce code, let's look at our common map file to see again what we're expecting to pass into mapf and what we're expecting to get back. We're expecting to get back a slice of keys and values. So we're going to want to create a slice of keys and values.
Yeah.
And we're going to eventually be returning that.
Okay, so if we go to the documentation for fields func, which is the hint they gave us.
Yeah.
Here's an example that I think is
exactly. That makes it way easier.
Yeah. So if you look at the example.
Yeah. So we're going to call fields func by passing unicode.isLetter.
Yeah.
Probably.
Yeah. So
and it'll do our entire job for us.
Yeah. Expand the example. That's the example they give.
Oh, priceless. Oh my God, dude. Genius. Well done. So I hate when they make weird shit like a rune. What the fuck is a rune data type? My God.
A rune? Maybe.
I have no idea. Sounds like something out of fantasy novels. Like Lord of the Rings.
A rune.
Yeah, let's deal with that later once our code fails.
A computer science term that's now used in language.
So we have our contents, which is just a straight up string. So we have this function f now.
Yep.
We can call it split words because that's what it's doing. And let's just print ln split words of contents. Yeah. Just to see.
I think you need string or field.
Oh, sorry, you're right. I'm doing this wrong. We're not actually using fields func.
Yeah. Yeah.
So we pass in contents and then split words.
Yep.
Those are our two arguments to fields func. And so fields func returns an array of strings, which is all of our words.
I think so, yeah.
And so what we're probably going to do is something like loop over. Man, I still don't know syntax for looping over stuff. And probably, I think this is the index and then word in range of result. What we're going to do is we're going to say data append equals append data word or something weird like that, or key value. You know what I'm talking about?
Yeah, totally. I just don't know the syntax for doing this.
For creating a key value? Yeah.
Yeah.
Let's look. Well, first off, before we actually do this for loop, like you were suggesting, let's just print out fields func result. So, like before, we'll run go run wc.go master sequential. My guess is, well, I'm not sure what master and sequential here are some pretty opaque things that the command line is doing to say run this sequentially. Okay.
Okay, undefined data.
So we're good. We needed to say data colon.
Yep.
Close. I'm a little worried that key value isn't in the namespace.
Yeah, we might have to do map reduce dot key value, but let's just try and get the results.
Okay, so we solved one problem, which was this needs to be colon equal.
What were the other errors?
Undefined Unicode, undefined strings. Okay. And then we're still going to get an error about undefined key value. So missing return. Oh, that's for the reduce function. So we're just working on the map function.
Yeah, what line was the undefined key value?
Sorry, come again?
What line was the undefined key value?
Oh, line 20 here. Oh, weird. Oh, bingo.
Yeah.
I gotta namespace it because it's used here successfully.
Yep.
So type MapReduce.keyValue is not an expression.
Okay.
Great. Okay. On line 20. So maybe we need to specify var data equals. I mean, it's straight up an expression here. It's probably how we declared this variable data.
Okay. Yeah.
Let's try again. Still not an expression. Well, we don't need it just yet. We're getting a result, right?
Oh, yeah. I'm not sure.
We don't need it just yet. We just want to print out result of trying to run fields func over our input. Missing return. So it still didn't print anything. So do we just need to write return?
In both functions.
Sorry, I'm doing all kinds of, yeah.
I think it's going to have to be an empty array.
Not enough arguments to return. Jesus. Oh, good point. Yep, you're right. We're probably going to need to instantiate something dumb.
Oh, this returns a string. Sorry, reduce returns a string.
Ah.
All right.
However, this is going to need to be some bizarre instance variable. Expected new line on line 33. Ah. Yeah, we're going to need to define an array of key values. And for some reason, I'm doing it wrong. So maybe it needs to be asterisk MapReduce.
Maybe you can look at the example from the test.
Oh, good idea. MapReduce test. MapF. This is an example. Their example. Oh,
so they define a response and then a pen.
Res is, yeah. We can say res. We can name our return value res.
Yeah, let's do that.
So res equals append res key value.
And then just return nothing.
Excellent observation. We might need to do the same for the reduce.
Okay.
Okay. Oh, okay. Okay.
Okay.
Getting close. Yeah, because we are not returning anything, or we're not adding anything to the result before returning from our map function. So it would make sense that our test run fails because the file's not being written.
Yep.
So we don't need to return data, but what we do need to do is loop over the words that are resulting from mapping fields func.
Yep.
It's hard to tell what this is an array of. I mean, it's got a closing.
It's just an array of words, which is what we wanted.
Okay, awesome. So looping over that array of words, we want to append to our result.
Yeah.
Key values.
Yeah, and instead of nil, let's just do the string 1.
Okay, we can do that. Oh, good idea, because we can just sum up those in our reduce.
Yep.
You suggested to look in our test to see an example of how they're creating key values. So, word, and we'll make it, well, it needs to be a string. I forgot. I think that's an important thing. Our key values are strings.
Okay.
We might need to cast our values to integers and then add them up. Kind of. But yeah, I think we are done with our map function.
Yeah.
Let's give our go run it another try. Undefined value. Yeah. Got to namespace it because we're no longer working inside of our MapReduce directory. We're working within our main directory.
Yep.
Ooh. Ooh. So it's going to fail on reduce because reduce doesn't actually do anything. And because this is sequential, it's doing all of the map tasks first before doing the reduce. So it's looping over all of the Project Gutenberg input text files before it fails on reducing.
Well, it's not going to fail. It's just running code.
Yeah.
It's just not going to give us the correct word count.
It'll probably poop because it doesn't have an output of a reduce step, because the reduce step doesn't have any file it writes out to. If that makes sense. Whew, this is hard, or this is taking a while. I can exit out of it and just say input only one text file.
Yeah, maybe let's start there.
Okay. So we're running pg star.txt, so we can just say pg, what's a shorter book? These are all super long books. Metamorphosis is a short story. Cool. Cool. Yeah, so it's getting to the merge step. It is completing.
Yep.
Reduced results are written to blah. Yeah. So we're getting merging of the 3 separate merge outputs because it looks like it's being ran with 3 reduce tasks. But that outputted merge result
is
yeah.
So now if we go back to the example from the test,
Mm-hmm.
What does the reduce function look like there?
The output file will be in here. And so, yeah, it doesn't have any counts yet. Sorry, you were saying again?
Let's look at the reduce file from the test from the example.
Oh, yeah. This?
Yeah.
So we want to edit wc.go. So we'll just mimic what's going on over here. Why not?
Okay, sure.
We need to,
or we could just return the length of string or values.
Oh yeah, you're totally right. So
I don't know how to get the length.
So what reduce f returns? What does reduce f return again? A reduce function?
The reduce function is just going to return a value of whatever we decide to do with the key and the array of strings that we got. In this case, it's just going to be an array of ones. So we can just get the length of the array.
And then cast that to
yeah, exactly.
So we don't even need to loop over anything.
Yeah.
So I don't know if this is right for sure.
I think it might be.
Going length of array. Actually, I think it might be values. Oops. Dot length.
Okay. Right.
Wow.
Length.
Oh yeah, you're right. Yeah. First time. Going cast integer to string. Yeah.
Yep.
Oh my god, not a function to do this. Let's look at Stack Overflow. There's got to be super fast. There's no super fast shortcut. We got to do that.
Okay.
Okay, Eureka, dude. Okay, so we need to also import string conv. String convert. Cool. All right, let's try running our against one Go file or one of our input files.
Yep.
Okay, and then there should be an outputted word count sequence file. So let's look at the head of that. Dude, looks good.
Yep, there we go.
All right, so I think we've just finished the second part of the lab. You can test your solution by timing it and whatnot. The output will be blah, blah. Your implementation is correct if the following command produces the output shown here. Okay, so we're going to need to run it, and it might take it says it should take about 15 seconds.
Okay.
It might take longer for us because our MapReduce has all of those logging print statements.
Yeah.
In fact, before we go any further, let's take that out, yeah? At least from our map step. I think that's it. So timing it, cool. While that runs, I'll take off screen share so I can look into your eyes. Starting MapReduce task. All right, this is going to take a little. It says it only takes. I'm looking at the lab, and it says you can test your solution using blah, and they time it, and it takes them 15 seconds.
Okay.
So it's been more than 15 seconds for us. Maybe they have a really good computer or something, or maybe we're doing something really dumb.
Yeah, it could be that we were doing something really dumb. For example, opening up and closing all those files, I think, is an optimization we could make.
Oh, for sure. Yeah, that's for sure. I'll let that keep running, but like you've just suggested, I'll switch over back to our MapReduce code and open up Common Map, which is, I think, where we're doing hell of file opening and closing.
File opening and closing.
I'll go back to screen share here now. Still running the MapReduce task. I'll just leave that running in the background. You can see?
Yep.
So I'm in Common Map file, and we're looking at our doMap function.
Okay.
And here's our. Come in? Oh, sure.
I need to go get a charger. I'll be back in just a second.
Okay, sounds good. Cool. It just finished. It took about 2 minutes 30.
Okay.
I'll screen share again. So we have our outputted file. So we're going to sort it, and we're going to tail the last 10 results.
Okay.
And see whether it matches what they have.
Fingers crossed.
He was that I am. Dude.
Looks good.
Freaking great. Yeah. Dude, let me create another PR. And we're just crushing it. I'll go back to the master branch. I'll make a new one called Lab 1 Part 2. And I'll add word count. Lab 1 Part 2 word count. And let me add the commands that you're supposed to run to test it and whatnot. Yeah, that opening and closing of files a ton.
I think that's causing the slowdown.
For sure. And it'll cause us problems as we get further into the lab.
Yeah.
But I'm opening a PR real quick on B. Jacobson 6824 Go Labs. Cool. Okay, dude, we're through. Dude, we've made way more progress than the first lab.
Let me go ahead and approve your PR.
Okay. Part 3, distributing MapReduce tasks. And part 4 and part 5 is extra credit. All right. Before we go any further, I'm going to go back to the course schedule and see how we're doing, all things considered. So we spent 2 hours last Sunday working on this. We spent about 2 hours today. So all in 4 hours. We've finished parts 1 and 2 of the lab. There's remaining parts 3 and 4, where 4 I think is optional, extra credit. No, it's not extra credit. Part 5 is extra credit. So we've kind of made it through half of the lab, and the lab is due after week 2 of the course. So all things considered, we're pretty much on track. If we were MIT undergrads or grad students right now taking this course, I think we'd be okay.
I think 4 hours.
Yeah.
2-week assignment. That's not bad.
Want to read part 3?
Half of a 2-week.
Yeah. It looks like if things kind of de-escalate over the next few weeks, with lab 2 being split up into 3 parts.
Yeah.
And then lab 3 being split up into 2 parts, and lab 4 being split up into 2 parts. Yeah, I'm really glad I'm not an undergrad right now. Want to check out lecture 2 rather than plowing further into this lab?
Sure.
I don't know how much it'll help us with the next few sections of the lab that we're working on now, but looks like before lab 1 was due in the class, lectures 2, 3, and 4 had happened, which we haven't read yet.
Yeah, I think RPC probably is going to be helpful.
Google file system, GFS, primary backup replication. Shall we check out lecture 2, or should we read a little further in the lab? Which do you prefer?
I don't know. It's up to you. I'm down either way.
I'm kind of pooped from the lab. What's up?
Just making it asynchronous, distributing it.
Yeah, part 3, which is what part of the lab we're on now. Our current implementation runs the map and reduce tasks one at a time sequentially. One of MapReduce's biggest selling points is that you don't do that. It can automatically parallelize your sequential code without any extra work. In this part of the lab, you will complete a version of MapReduce that splits the work over a set of worker threads that run in parallel on multiple cores. While not distributed across multiple machines, as in real MapReduce deployments, your implementation will use RPC to simulate distributed computation. The code in MapReduce master.go does most of the work of managing a MapReduce job. We also supply you with the complete code for a worker thread in MapReduce worker.go, as well as some code to deal with RPC in the common RPC file. Your job is to implement schedule. The master calls schedule twice during the MapReduce job, once for the map phase and once for the reduce phase. Schedule's job is to hand out tasks to the available workers. There will usually be more tasks than worker threads, so schedule must give each worker a sequence of tasks one at a time. Schedule should wait until all tasks have completed and then return. Schedule, all right, this sounds pretty Go heavy because it's going to be dealing with threads.
Yeah, or Go
channels.
Go functions or whatever.
Schedule learns about the set of workers by reading its register chan argument. So that's probably the array of channels that are workers listening for work. Or it might be a function to retrieve that list. That channel yields a string for each worker containing the worker's RPC address. Okay. Some workers may exist before schedule is called, and some may start while schedule is running. All will appear on register chan. Schedule should use all the workers, including ones that appear after it starts. Okay. So there's going to have to be some mechanism in the schedule function that, in waiting for results from tasks, is attempting to invoke register chan and push down any pending tasks to new workers that become available.
Yeah. So we have to, maybe we should just run the test and see what output we get without changing anything.
Okay. So go test -run test basic. Have you merged my PR? I guess that's unrelated.
No, but I can.
Okay. So I'm back on master branch. I'll git pull. I'll do git checkout FB lab 1 part 3.
Pull master one more time.
Okay. Oops. Okay. And I'll cd back into the MapReduce directory wherever you want to test from. Cool. 100 map tasks. Oh. So there's these lock and unlock methods. There's 100 map tasks where previously there was like 1. 50 reduced tasks where there was previously 1. And there's this registration server, which is where worker processes or threads register themselves with our scheduler. Okay. Okay. Fail, because we don't write any. We're not writing any result file.
Yep.
From our
Okay.
Okay. Yep. That's a failing test.
Okay.
This is gonna require a lot of nitty gritty.
Yeah, we're gonna have to go kind of deep for this one.
How are you feeling energy level wise? Do you want to punt on this till next weekend?
Yeah, maybe we should just wait for next weekend.
Do you want to spend any time checking out the lecture 2, real quick, about RPC and threads and crawler and key value?
Yeah.
Oh, the crawler and key value are just Go files demonstrating distributed web crawling, which is pretty cool. And then there's the key value. It looks like it's a server, RPC for server for kind of like Redis.
Yeah, it's RPC for key value server.
It's maybe like under a couple hundred lines of code, which is pretty rad.
Yeah, I think it's. I've not used the Go RPC library, but I'm guessing it's pretty solid.
Yeah, well, it's unclear whether this persists your keys and values to disk at all. So there's very little guarantees.
Oh, sure.
Which is similar to Redis.
Yeah.
But web crawling is a really cool application. Crawl serial, so crawling things serially. This doesn't do, concurrent. So you can concurrently crawl a ton of URLs.
Yeah.
Okay. Well, those are just sample codes for the second lecture.
Okay.
Interestingly, distributed systems used to use C++, the course at MIT.
Yeah.
Students spent time fixing bugs unrelated to distributed systems. Sounds familiar.
Yeah.
Go allows you to concentrate on distributed systems problems, if you say so. Yeah. Good support for concurrency, good support for RPC, garbage collected, type safe.
Yeah.
It sounds like the lecturer or the professor just likes Go. Simple language to learn. Fashionable language when we redid distributed systems class, suggesting that it might not be fashionable anymore.
Maybe it's mainstream.
Oh, yeah. It's not just fashionable, it's mainstream. After the tutorial, there's a idiomatic blog post.
Okay.
We can take a look at that on our own.
Yeah.
Russ Cox, who's one of the creators of Golang, is a guest lecturer of the distributed systems class. That's pretty cool.
Yeah.
I think the core team that works on Golang, or were the original creators of Golang, are in Google's Boston offices, which are right next to MIT.
Yeah. I guess that's one of the benefits of going to MIT.
Yeah, freaking A, for sure. Threads. Threads are a useful structuring tool. Go calls them Go routines. Everyone else calls them threads. Wow, that's rad.
Okay.
Why threads? Concurrency. That's very common.
Yeah.
Input-output concurrency. Multi-core.
core. Excellent.
Thread. You want to read some of it for me?
Yeah. Thread, thread of execution. Threads allow one program to logically execute many things at once. The threads share memory. Each thread includes some per thread state, program counter, registered stack, etc. How many threads in a program? As many as useful for the application. Go encourages you to create many threads, typically more threads than cores. The Go runtime schedules them on the available cores. So Go threads are not free, but you should think as if they are creating a thread is more expensive than a method call.
Okay.
Okay. Threading challenges, sharing data. One thread reads data that another thread is changing. It can lead
That's
to
a problem.
conditions. Yep. So we need to use something like a mutex. Coordination between threads. Wait for all map threads to finish can lead to deadlocks. Typically easier to notice than races. So we need to use Go channels or wait groups. And granularity of concurrency. Coarse-grained, simple but little concurrency parallelism. Fine-grained, more concurrency, more race, and deadlocks. I'm not sure what the difference between coarse-grained and fine-grained is, but
maybe like having RPCs that do a lot more work or operate on bigger batches of data, like your batch size.
Yeah.
Yeah, there's like a trade-off of how large you make your batch sizes with MapReduce, and how many threads or how many units of concurrency you've got.
Yeah.
But if you use a billion different, if you use a concurrency of a billion, you're going to be spending so much time interacting with your locking mechanisms or mutex that
you're not going to get a lot of work.
Yeah, exactly. And you pay this cost, like they say, of starting up a new thread is more expensive than invoking a function.
Yep. Okay. Crawler exercises, 2 challenges. Arrange for I/O concurrency while fetching a URL. Work on another URL. Fetch each URL once. Want to avoid wasting network bandwidth. Want to be nice to remote systems, so maybe like a backoff or a waiting.
Sounds familiar.
Work on different URLs on different cores.
Yeah.
Crawler, okay.
So that was the code sample they had?
Yep.
They're just talking about what's in that file. We kind of looked at it.
Yeah.
We can take a look at it when we get to the lab that involves these Go features.
Okay.
Because they're pretty intense. Like how to create a thread in Go. Why you should lock things. Why removing locks makes everything look like it works faster. What can go wrong? How to do atomic writes when you have multi-threading. How to prevent work from being performed more than once.
Yep.
Which is a really big problem. For example, if you're like paying people or if you're performing an RPC that actually costs you money.
Yep. You want to make sure that's done once.
Race condition, yeah. Ooh, cool. Go can detect races for you.
Oh, interesting.
How can we decide we are done with processing a page? Some wait group function. Channels, this is a Go specific word or terminology. General purpose mechanism to coordinate threads. So I've heard that this was like one of the more popular features of the language, but whether people actually use it or not in practice is another question.
Yeah.
Bounded buffer of messages. So trying to avoid buffer overflow automatically, I guess.
Okay.
Or allocate resources before anything else. Several threads can send and receive on a channel. Go runtime will lock things automatically for you. That's nice.
Yep.
Sending or receiving can block. Dispatch every URL through a master thread. No races for a fetched map because it isn't shared. Okay, I kind of get that. You kind of get that?
Yep.
What's the best solution? All concurrent ones are substantially more difficult than the serial one. Some Go designers argue avoid shared memory, use channels only. My lab solutions use many concurrency features. Locks when sharing is natural. Channels for coordination between threads.
Okay.
So we can try out Go's race detector when we're working on the portion of lab that works with RPCs. I think RPCs are lab 2, actually.
Yeah. So MapReduce doesn't do a lot of sharing, right? Like that's specifically not sharing.
Yeah. I mean, there's communication between master and worker.
Yeah.
When there's the map task phase, and then there's the reduce task phase, and that the master process needs to be made aware of or monitor the state of the worker, whether it's working on map task or a reduce task.
Yeah.
So yeah, there is concurrency, but yeah, you don't share much besides state and results. A key piece of distributed RPCs. Easy to program network communication. Hides most details of client-server communication. Client call is much like ordinary procedure call. Server handlers are much like ordinary procedures. RPC is widely used. Well, yeah. It's everything on the internet ever. RPC ideally makes net communication look just like a function call. Yeah, agreed. Go example, the key value.go file. That's the Redis example. Client dials server, invokes call similar to a regular function call. Server handles each request in a separate thread, concurrency, thus locks for key value. RPC message diagram, you have your client request communicating to the server, and the server responds. Software structure, yeah, this is very educational.
Yeah.
A few details, which server function to call. In Go, specified in call. Okay. Marshalling, what data format to use. It's tricky to marshal complex data structures. Go's RPC library is pretty powerful. Some things you cannot pass. For example, Go specific data functions. Or
functions makes sense.
What do you call channels and functions? There's like first class data structures and second class data structures. Or like where functions are treated as first class citizens, you know?
Yeah. Yeah, but in this case, like a channel is like something that's very specific to your local running program. So it doesn't make sense to share that across an RPC.
Yeah.
It's like, how are you going to marshal a function and then have it? Like that's like I don't know, the shared code between two things.
Yeah. Binding, how does the client know who to talk to? What to do about failures? What does a failure look like? Client never sees a response from a server. Client does not know if the server saw the request. Maybe server net failed just before sending a reply. Simplest scheme.
At least once behavior.
So yeah, this is where our lab problems are going to be headed, is how to cope with degrading connectivity between your different threads or processes or servers or clients. Is at least once easy for applications to cope with. Depends on if your tasks are idempotent and not financially expensive. Simple problem with at least once. Client sends, deduct $10 from bank account. Yep, that's a problem and expensive. What can go wrong with this client program? Putting 10? A lot of things. It's hard to know which write worked.
Yep.
Is at least once ever okay? Yes, if it's okay to repeat operations. For example, read-only. Yes, if application has its own plan for coping with duplicates, which you will need for lab 1. Okay. That's probably something that will come up in the next 2 parts of the lab. Better RPC behavior at most once. Idea, server RPC code detects duplicate requests, returns previous reply instead of rerunning handler. How to detect a duplicate request. Client includes a unique transaction ID with each request. Uses same transaction ID for resend. That makes a lot of sense. We're almost done. Some complexities to doing with the at most once model. This will come up in labs 3 and on. How to ensure the transaction ID is unique. Big random number, combine unique client ID with sequence number. So like the number transaction that client is trying to perform.
Yeah.
Server must eventually discard info about old RPCs. When is discarding safe? Unique client IDs, per client RPC sequence numbers. Client includes a seen all replies less than or equal to X with every RPC. Much like TCP sequence numbers and acknowledgements. So this is an idea that I've seen recently with Kafka and other distributed logging services is log compaction, which sounds similar to this problem of when is it safe to discard old logs? And if you can come up with a way to compact your old logs in an effective way, you can eliminate old ones. Only allow one outstanding RPC at a time. Okay. Client agrees to keep retrying. Server discards after a certain number of minutes.
Yeah.
How to handle duplicate request while original is still executing. Server doesn't know reply yet. Don't want to run twice. Pending flag per executing RPC. What if an at most once server crashes and restarts? If at most once duplicate info is in memory, server will forget and accept duplicate requests after restart. Maybe it should write the duplicate info to disk. Maybe replica server should also replicate duplicate info.
Yeah.
Oh, for sure. Wow. So file systems have this with journaling, which is exactly what they're talking about. What about exactly once? At most once plus unbounded retries plus fault tolerant service. That sounds like the third lab. Go RPC is at most once.
At most once. Okay.
So this is just about how Go's RPC libraries works, I guess, which is not inherently super crazy interesting.
So it sounds like Go's RPC is just like it tries once, and any failure it kind of just fails. So it's kind of up to the implementer to figure out,
handle failures and
what they want to do.
All right, man. Well, we got pretty far. We read the second lecture, and we got halfway through the lab. I think I'm pooped. I gotta get another coffee.
Yeah, sounds good.
Yeah. Well, I know there were some people that joined on. Nobody dropped a message in the chat, but we'll see how well prepared and schedule wise whether we can do this next Sunday as well.
Yeah, sounds good. This was fun.
Awesome. I'll stop the broadcast.
All right, sounds good.